So this is what our fundamental counting principle tells us. If they want to know how many different types of sandwiches can be made, if I have 2 types of bread, 2 types of meats, and 3 types of cheeses, have you guys done this before where you figure out how many different types you can do? Well, what we do is we multiply the numbers of options we have together for each of our situations. We have how many types of bread? 2. So we've got 2 types of bread. How many types of meat? 2. And how many types of cheese? 3. So we're going to multiply these together. It's going to tell us how many sandwiches we can make with these combinations. So 2 times 2 times 3, and that makes 12 sandwiches. So our sample space would have 12 different sandwiches in it. We could have, let's say they're white and wheat bread. White bread, ham, pepper jack, white bread, ham, Swiss, white bread, ham, American. Wheat bread, ham, pepper jack, wheat bread, ham, Swiss, wheat bread, ham, American. That's 6 of them. Now we'll do our turkey. White bread, turkey, pepper jack, white bread, turkey, Swiss, white bread, turkey, American. Wheat bread, turkey, pepper jack, wheat bread, turkey, Swiss, and wheat bread, turkey, American. So that's all 12 of our options. Okay. So that is how we figure out how many items are in our sample space. So we're going to count some in these examples that follow. We're just going to see how many outcomes there are. We could list them if we need to. We have a spinner. It can land on red, blue, green, or yellow, and we're only spinning it 1 time. How many possibilities do we have? How many outcomes could there be? Y'all can hold your fingers up. We can spin. We have a spinner. Remember the spinners that you have, and they're split up, and we've got red, blue, green, yellow. How many possibilities do we have? 4, right. So the number of outcomes in our sample space, there are 4. We're only spinning it 1 time, so we don't have to do any multiplying. We're just counting. Questions on number 1? Okay. On number 2, it says a new car is available in a sedan and a hatchback, and it's available in red, white, green, and black. So we want to figure out how many combinations of cars we could have. We've got sedan and hatchback, and it can be in red, white, green, or black. So we want to know, we're going to do type of car and color so we can see how many options there are. Type and color. How many types of cars do we have in this situation? There's 2, a sedan and a hatchback. Sedan is just your 4-door car. Hatchback is normally 2-door with like a trunk, right? And it's available in red, white, green, and black. How many colors? 4. So how many different possibilities do we have for our cars? 8, right? 2 times 4, and that makes 8. It can be a sedan that's one of those 4 colors, or a hatchback that's one of those 4 colors, and that makes 8 altogether. Questions on that? Okay. All right, our next one, we have 6 rooms that need to be painted, and each room can be painted white, yellow, or pink. So we're going to see our things. We've got 6 rooms, so I'm going to make 6 spaces I have to fill in. 1, 2, 3, 4, 5, 6. This is room 1, 2, 3, 4, 5, 6. Each room can be white, yellow, or pink. So how many color options do I have for my first room? 3, right? It could be white, yellow, or pink. So I got 3 options for my first room. For my second room, how many color options do I have?
Is it still 3 or is it 2?
It's still 3. Once you paint a color, you could still use it. It doesn't tell you like that you took that one away. And so do you think it's 3 for all of them? Because they can each be white, yellow, or pink? Yeah. So to see all the different combinations we could have for this room, we're going to do 3 times 3 times 3 times 3 times 3 times 3. Or 3 to what power? 3 to the 6th power, yeah. That's 729 different ways that we could paint these rooms. The first room could be pink. This one could be white. This one could be yellow. The rest of them could be yellow. It could be white. It could be white. It could be yellow. It could be pink. Could be white. Could be pink. There's 729 different ways that we could paint those rooms. Would any of you want to live in a room where all the walls were painted white, yellow, or pink? White and yellow, that's okay. I don't need a bunch of pink rooms. So fundamental counting principle, we take the options for each of them, we multiply them together. We all good there. Okay. All right, we have 2 other types of things, and these are called either permutations or combinations, and they differ just slightly, and the way that we calculate them differ as well. So we will have to use Desmos for this, or if you have a school calculator or just a regular calculator like that, you could do it too. So a permutation is an arrangement of things in a specific order. So if I had the letters A, B, C, how many different ways do you think we could arrange the letters A, B, C? Just put it in the chat, just a guess. Just real quick, how many ways do you think we could arrange these letters? 9, good guess. 12, another good guess. 7. All right, y'all are all really close. Let's write them all down and see what it is. So we have A, B, C. We could have A, C, B, right? We could have B, A, C and B, C, A. Are those all the ones that start with A and B? Is there any other way to start with A and B? Okay, so now we'll go to C. C, A, B, and C, B, A. Nothing else would start with C because we already mixed those up. So how many different ways can we arrange the letters A, B, C? There are 6 different ways, okay? And so we can use the fundamental counting principle to get that number. And this is how we're going to do that. So we can figure out that number without having to write them out, which is fine if you have like 3 things. But if you have like 7 things, you don't want to have to try to write them out. So how many spaces do we have to fill for A, B, C? We've got 3 spaces that we're filling, right? So we're going to fill 3 spaces. First letter, second letter, third letter. And we have first, second, third because our order matters in this. How many options did we have when we were choosing our first letter? What goes in our first spot? We could choose A, B, or C, right? So in our first spot, we had the choice of all 3 of them, okay? But after our first letter, one of them was already used because now it's in that first spot. So when we go to the second spot, how many options did we have? We had 2 options. Now one of those gets used, and how many options do we have for our last spot? There's 1 option, and we can kind of see it when we were doing the one of these. Like if I started here, I had 3 options for here, but now A's been used, so I could only use B and C. And then if I pick C, all that I have left is the B to choose from. So 3 times 2 times 1, and that equals 6. And that's how many things that we had. Okay. what's kind of neat is sometimes you don't want to have to type all of this, the 3 times 2 times 1, especially if it was like 10. You don't want to do 10 times 9 times 8 times 7 times 6 times 5. So there's an operation, and it's the exclamation point. Did you see that on the ACT, or have you seen that on anything where there's an exclamation point? That's called factorial. And that's our exclamation point. So if I had, oh, it turned to red. I did not do that. Jesus, Louises. 3 factorial is the same thing as 3 times 2 times 1. Anything factorial, you take that number and you multiply all the way down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Occasionally, we don't use all the numbers with permutations, and we'll get there in a minute on how you calculate this. So for A, B, C, if we were arranging that, we did 3 factorial because there were 3 letters and we're filling in all the spaces. So 3 times 2 times 1. So if I wanted to see how we would do doubles, when it says unique permutations, that means mixing the letters up. How many different ways can we mix up the letters in doubles? Well, how many different letters are there in the word doubles? So 1, 2, 3, 4, 5, 6, 7, right? There's 7 different of them. If we want to mix them all up, we can write our 7 spaces and do 7 times 6 times 5 times 4 times 3 times 2 times 1, or just write 7 factorial. You can do whichever one you want. And that's how many different ways we can arrange the word doubles. I'm going to see if on Desmos they have the factorial button. I'm going to double check. Oh, they do. Great. Okay, I'll just put that up here and show you the screen. So you know how to do this on Desmos. Can y'all see my Desmos webpage? Is that what's up right now? Okay. So when you go to desmos.com, you want to click Math Tools, and we want a scientific calculator. And then function is where we're going to get more of our things that we can use. So that's all of our square root and trig stuff. But if you hit the function button, you see the exclamation point at the bottom here. So I wanted 7 factorial. So 7 factorial. You could probably just type in an exclamation point on the computer as well. So our answer is 5,040. Okay. Any questions on how to use the Desmos calculator for that? You're just doing the exclamation. I'm going to make sure if I just type in an exclamation point. Yeah, you don't even have to go to the function. You can just type the exclamation in. That is 5,040. You could also do 7 factorial, which is 5040. Look at the word equation. To know how to permute these, or how many different ways we could write equation. How many letters are there in equation? There are 8 letters. So we can write all of our spaces out, or we can just say 8 factorial. And that is 40,320. Yeah, you do the exclamation point just so you don't have to type it all in. It's just a shorthand for that instead of having to do all that part. So are we all right arranging things for our permutations, putting things in a certain order if we're using all of them? Yep. Okay. All right. So we have combinations left. So combinations, we're going to pick groups of things, but we're not putting them in a specific order. So for permutations, the order matters. Once you pick your numbers or mix them all up, we really care about what order they're in. But for combinations, you don't. Oh, I forgot about this one. So we are going to see if we're taking A and B, A, B, C, and D, we're going to pick 2 letters at a time. We want to see how many permutations we can have if we're picking 2 of those letters at a time. So you could have like A and B, that's one. BA, that's another. AC is one. CA is another. How many do you think we could have? Just give me a guess in the chat. Good guess. Good guess. Good guess. Let's write them all out, and then I'll show you another way we can calculate that. We'll use Desmos for that as well. So we're going to write them out in pairs, and the order matters because it says permutation. So we've got AB, right? AB, and then what goes with that? BA as well. AC and CA. AD and DA. Is that all the ones that start with A? Okay. And then we've got B. We already did the BA, so we'll do BC next. BC, and that goes with CB. BD, and that goes with DB. Is that all the ones that start with B? Okay. Now we'll go over to C. I already did C with A and C with B, so I'll have to just do CD and DC. Did I get every single one? The 3 that start with A, the 3 that start with B, the 3 that start with C, and the 3 that start with D. So how many was that? There are 12. So there are 12 total. So let's see if we can use what we know about permutations to figure out that that was going to be 12 without having to write them all out. So how many spots were we filling? How many places did we have to fill? We were taking how many at a time? We were taking 2 at a time, okay? We were taking 2 at a time. We had our first letter and our second letter. How many options did we have for our first letter? We had 4 to choose from. We could choose from all 4, okay? One of them got put in that place. So how many options were there for the second number or second letter? There are 3, right? So we had 4 options for the first one, but then one of them got taken away because we used it. Then we have 3 options for the second. So what is 4 times 3? 12. So we started, there could be 4, but then we used 1. We weren't going to use it again. Then there were 3. For permutations, there's a shorthand for this, so you don't have to write it all out just like we did before. And it's this thing, it's an NPR. You probably saw that maybe on Desmos when we were looking at it. For NPR, the N stands for the total that you started with. And the R is how many that you are placing or how many that you're taking or putting in there. So with this one, we've got 4 total and we're going to place 2. We just want them in 2s. So ours in this problem would be 4P2. And that's going to be 12. And I'll show you how to do the 4P2 if you don't want to list it out like this. So go back to Desmos. It's your function button. Do you see the NPR at the bottom row? So click on that one. It's going to come up with a thing with commas, and you want to tell it the N first and then the R. So how many total were we choosing from on that last one? 4. And we wanted to place 2. So I say 4, 2. And what did it tell me the answer was? 12. Okay. So if you don't want to do all of that, you might want to do it. Hey, Taylin, I know that conversation that you've been on for 20 minutes is probably important, but let's go ahead and put our phone down, okay? Thank you. All right, so now we've got combinations. Do you think that there is something we're going to use for combinations that's also on the bottom row? We had permutations, it's NPR, and combinations, what do you think we're going to use? The NCR, yeah. So we just have to know the difference between the two of them and how you pick. And so I'll show you the difference between. For combinations, we are choosing groups, but those groups don't have to be in any particular order. It's like I have a classroom of 5 people and I want to choose groups of 2, but I don't care who comes first and second. So for these, we do NCR. So we're choosing groups. The order does not matter. I just want like a group of 5 or a group of 8 or a group of 10. Or if we were looking at the one above, AB and BA would be the same thing because it doesn't matter which one came first. So if I were doing combinations, how many combinations would I have in this problem if I had 4 of them and I just wanted a pairs? How many different pairs would there have been? AB and BA would be the same. This would be the same. That would be the same. That one, and that one. So there's only 6 pairs. A and B, A and C, A and D, B and C, B and D, C, D. Because it didn't matter what order they went in. So for a combination, in this particular situation, if I did 4C2, it would only be 6 because it doesn't matter which one came first and which one came second. Okay. So we have got 4 at the bottom, and we have to pick if they're permutations or combinations. And then we're going to see if we need to do NPR or NCR. Number 14. A team of 14 lacrosse players needs to choose a captain and a co-captain. Are captain and co-captain 2 separate jobs? Are they 2 separate jobs to be captain or co-captain? Do they do different things? Yeah, so it would be different. So this is going to be a permutation because you're going to have a different amount whether someone was captain or co-captain or vice versa. So this one is a permutation because we have 2 specific slots to fill. We've got to choose a captain and a co-captain, and they are different. So how many total people did we have to pick from? How many total altogether? How many people are on the team? 14. And we want to pick how many slots or how many places are we filling? 2, captain and co-captain. So this is going to be 14P2. And you can go to Desmos and do the 14. I'll just erase these. We had 14 and we are picking 2. And that's 182 options. Number 8, we want the combination of, we're doing 3-digit lock. We want to use 3, 8, and 1, and we want to see how many different ways we can do 3, 8, and 1. We can't use them over and over and over again. I'm just going to do this one this way, and then I'll show you. When you're doing a combination lock, are the numbers that they're in, is that a specific order? Like if you were doing a lock, would you 3, 8, 1 wouldn't be the same as 8, 3, 1, would it? It wouldn't both open it. So in this case, our order does matter when we're listing them. So it is going to be a permutation. I don't know why they said this in there, but we need to know what order they're in. How many options did we have for our first one? We're only using 3, 8, and 1. How many different numbers do we have to choose from? 3. Okay. We already used one of them. So how many do we have for the next one? 2. Then how many for the last one? 1. And we already did one of those, and we know that's going to be 6. If you were doing it with the NPR, we had how many numbers to choose from? 3. And how many were we placing? 3. And that's going to be 6 if you put it into the calculator. So those were both permutations. It's going to be pretty obvious things are going in an order, or they have specific job titles for them. So if you see like president, vice president, captain, co-captain, things like that, you're going to have a permutation because it matters where they are in the list. Okay, number 9, we have 30 people to go on the elevator. They're going to be going in groups of 6. So you're just taking a group of 6 people and putting them on an elevator. Does it matter who gets on that elevator of that group of 6, first, second, third, or are they all just going to be traveling together? Okay, so do we need a P or a C? A C, right. A permutation, you're putting in a specific order. A combination, we're just taking a group of folks and they're just all coming together, okay? So it doesn't matter that one group, they could move around in the elevator, they would still be that same group of people. So this one is a combination because we're doing groups. How many total people do we have to choose from? 30. And we're going to choose groups of 6. So when I do the P's, I always think about placing in a specific order, and C's, I always say choose a group. So 30, C6, I can do that on Desmos. Click the NCR, 30, comma, 6. Oh my goodness, that's huge. So there are 593,775 ways. All right, so 593,775. Okay, number 10, I want you to read it, and then we're going to vote whether you think that is a permutation where we are placing people in a specific spot, or a combination where we're just getting groups of folks and it doesn't matter who's who or who is where. So I want everybody to read through, and every single person is going to vote.
Is it? Can I say what I think?
Well, I'm gonna have you all raise your hand, and then you can tell me why you think it is what you think. Okay. So everyone read through. Devin, did you read through this problem? Devin, can you hear me? He has me on mute. Tragic. He's missing all this lesson. What a shame. Okay. All right, so let's vote. If you think it's a permutation where we're putting things in a specific order, raise your hand. If you think it's a combination where we're choosing a group and we don't care what order they're in, raise your hand. All right, that's good. We had a few for a permutation. We had a few more for a combination. Donovan, tell us why you think it's a combination.
Because it just said a team. It didn't say like who specific, like exactly what team. It just said a team, you know, and it said 11 basketball players. So and it just said choose two. It didn't say which two. It just said two.
Yeah, you're choosing two, and you're just telling those two to refill the water cooler. It's not like choosing two and then one's going to go first and one's going to go second, and that part's important. It's just you're just choosing two people. Those two people are going together to fill the water cooler. So it doesn't matter if it was like Donovan and Devin together is the same thing as Devin and Donovan. You see what I'm saying? So Devin and Donovan together are a group. Mixing their names up doesn't change the fact that they're still in that same group. If I said, we are going to go fill up the water cooler and someone's going to fill it up in station 1 and someone else is going to fill it up in station 2, Devin over here and Donovan there is different if I was giving them specific places to go. But this is just, we're in a group, just like we're in the elevator together. We're doing that together. We don't have specific jobs in that group. So it is a C. It is a combination. We are just choosing two players. We don't differentiate between what they have to do. So 11, because there's 11 total, and we are choosing two, and they don't have specific jobs. And just because it says choose doesn't always mean it's a C. This one does say choose on number 7, but they had specific jobs. We had a captain and a co-captain. This is just choosing two players. They don't have anything separating them. So 11C2, if we type that into Desmos, I think it's 100 and no, it's not 110. I think it's 55, but we'll double check. Just did that in my head. So it could be wrong. 55, okay. And that is 55.